Hello everyone. Today we are going to complete our lesson Optical Phenomena. Okay, our part for today is about atmospheric refraction. During this chapter, we talked about refraction a lot. We said refraction, it's when the light bends or refracts as it passes from a medium to another. It can bend either toward the normal or away from the normal. Okay, and in this section, we talked about a new concept called total internal reflection. We said when the light passes from a medium which is more dense to a medium which is less dense, it will bend away from the normal, right? But if the light passing from a medium which is more dense to a medium which is less dense with an angle of incidence equals to the critical angle of the substance, here maximum refraction will occur in the second medium, and the refracted ray will touch the boundary and it will make an angle of 90 degrees with the normal. And we said, so when any ray coming from the medium which is more dense with an angle of incidence more than the critical angle, this ray is not going to refract at all. It's going only to reflect and doing the total internal reflection. Today's part is about applications of this total internal reflection in our everyday life situations. The first one is about the twinkling of stars. Have you ever wondered why does the twinkling of stars occur? Also, girls, we have other situations that occurs because of this refraction. Scientists also observed that we observe, girls, the sunrise sometime before it actually rises, and we observe the sunset sometime later after it has already set. Why do all of these effects occur? They occur because of atmospheric refraction. I will explain for you the twinkling of stars, and if you want to know more about the sunset and the sunrise, I can put for you a video to see it. Okay. Atmospheric refraction, first, it's a term that refers to the change in the path of light as it travels through the layers of our atmosphere. Maybe now you are going to wonder why refraction will occur in air. Air is one medium, okay? We don't have here two different media. So why we have refraction? We learned that refraction occurs when the light changes speed, when the light changes medium. We know that light changes speed when it changes medium, like going from air to water, from air to glass, from glass to water. Okay, so here you have to pay attention on something. The air, okay, it's only one type of medium, air, but girls, it's not uniform, but it's not a uniform medium. What means not a uniform medium? It's not the same everywhere. The fact near, for example, the outer layer of the earth is less dense than the layer which is close to the surface of the earth. Okay, so we have different layers of air, each layer with a specific density. So actually when the light passes through the air itself, it changes speed, and this slight change of speed causes the air to bend. Okay, let's see this video together.
During the night, stars appear to twinkle, while in reality they do not. The cause of this apparent twinkling is due to atmospheric refraction. As light rays from the stars travel through the layers of our atmosphere, they bend towards the normal.
Girls, as you can see here, the light coming from the stars, okay, from the vacuum, and we learned that the light has its maximum speed in vacuum, 3 times 10 to the power of 8 meters per second, and when it enters air, its speed decreases. Okay, so here it's entering different layers of air. This layer, it has less density than this, and so on. And we learned that when the light passes from a medium which is less dense to a medium which is more dense, how will it bend? See, this is the normal, and this is the initial path of light. Will it bend toward our normal or away? It will bend toward, because it's going to slow down. Okay, so it's going to slow down. So this happens when the light coming from a star enters our layers of air around Earth. Let's continue.
They bend towards the normal. The change in the densities of air in the path of light makes the stars appear to continually shift from their position and gives an impression of flickering, which we refer to as twinkling.
Okay, so what happens here? So girls, we get the light coming from the actual position of the star, but this light, it refracts many times before reaching our eyes, because it has passed through different layers of air with different densities. Okay, so we get, for example, a specific a path of light, and as we said before in the previous chapter, that any light that enters our eyes, the brain believes that this light has traveled in a straight path. So we get, for example, this path of light. The brain assumes that this light has traveled in this path, okay, and we think that the star is here, but this is not the actual position of the star. This is the apparent position of the star. So therefore we see the star. So when we like walk or look at the sky, we see the star like flickering, and it gives us the impression of twinkling. Okay, so this is the first one about twinkling of stars, which is caused by atmospheric refraction. Summary: atmospheric refraction is the change in path of light as it travels through layers of atmosphere. Light rays bend toward the normal when passing from a less dense medium to denser medium. The twinkling of stars is caused due to the atmospheric refraction. Now we'll talk about another phenomenon caused by atmospheric refraction. Let's read this story. Imagine you're in the desert, you're lost, you've been walking for hours, you've run out of water. On the horizon, you see a giant shimmering puddle of water. Yippee! You shout, you're saved. But it's not a puddle of water, it's a mirage. Mirages are optical illusions that have fooled many thirsty explorers. Let's say seekers together, what is mirage? So maybe if you didn't see it before in the desert, maybe you saw it on the road. What can you notice here? When you are far, okay, you see like puddle of water on the road, but when you reach that point, you see that there is nothing. Okay, so this is mirage. Mirage, it's an optical illusion. It's not a real puddle of water, and it's caused by the atmospheric refraction. I will explain how it forms. Look here. First, we talked about uniform medium and non-uniform medium. A uniform medium is the medium that's the same everywhere, from its top boundary to its bottom boundary, and from its left boundary to its right boundary. But not every medium is uniform, such as the air. The air can sometimes be non-uniform medium, and this leads to an interesting refraction phenomenon, which is the formation of mirages. Why this leads to an interesting refraction phenomenon? Because, girls, when the air is non-uniform, it means it doesn't have the same density everywhere. In a layer, it is more dense than the other, and therefore, when the light passes through these layers, it will refract, it will bend, because we learned that the more the density of a substance, the slower the light will be in this substance. Okay? So let's see here together. Let's say that the light is coming from the sun. Okay, so this group of light is coming directly to your eyes. You see it normally, but this group of light is going from the sun to the sand, and in a hot day, the sun heats the sand, and the sand becomes very, very hot, and it heats up the layer above it. So here I got above the sand hot air, and at higher elevation, I have cool air. So here I have like different layers of air. This one it's cool, which is at higher elevation, and the one which is very close to the sand, it's hot. Okay, so the light coming from the sun is passing first through the cool air, then through the hot air. Okay, which one is more dense first? Is it the cool air or the hot air? What do you expect? Hot air, it means high temperature, and we learned in previous chapters that temperature, it is the kinetic energy of particles. When temperature increases, the air particles move faster, they occupy more space, and therefore they become what? Less dense. So this part is less dense. The hot air is less dense than the cool air. So what do you expect? When the light passes first from cool air to hot air, it bends, right? How does it bend? Away or toward? When the light passes into a medium which is less dense, we know that it speeds up. When it speeds up, how does it bend? Bends away. Okay, it bends away from the normal. And here, girls, it hits the desert and the sand, and reflects. So you get it. Okay, reflects into your eyes. Okay, and we know that the brain always, girls, assume that the light has traveled in a straight path. Okay, so this, we got this one, the black one. Okay, the brain traces it back, and we think that the source that gives us this ray is here. Okay, but this is for sure not the actual source. This is just a virtual image. Okay, so we think that this is the source that gives us this black ray here, but the actual source is where? Is the sun. So the puddle of water that we see it on the sand in the desert, it's just a virtual image of the sun on the sand. Let's see this one together.
What is a mirage?
An invisible cloak!
No. Mirage is an illusion in which it appears as if there is water present on the ground. On a hot day, the land heats the layers of air closer to it. However, as we move higher, the layers of air get relatively cooler. Thus, the hot lower layers of air near the ground form rarer media, and cold upper layers form denser media. Now, when light coming from sky travels from denser to rarer media, it bends more and more until it exceeds the critical angle, that is, the angle beyond which light gets reflected. This phenomenon is called total internal reflection. When this reflected light reaches our eyes trace it backward as a straight line. Hence, the reflection of blue sky appears on the ground, and our brain thinks that there is water, thus causing a mirage.
Okay. Now we will see also how can the mirage let us see like a tree which is inverted like here. Okay, the same thing if you are in the desert, so the ground is very hot, so it warms a layer of air above it. Okay, so the air at a higher elevation is more cooler. So here we have different density of the air. So the light coming here, if I want to talk about the tree, I have like two group of rays. The group A, the light coming directly from the tree to our eyes, it will enter our eyes directly and no problem with it. We will see the tree upright, but the tree is giving rays in all directions, and some of these rays are directed toward the ground. So this group of ray is moving from cool air to hot air, so it will refract, it will bend. How will it bend? It will bend away because it's entering a medium or a layer, it's better to say a layer of air which is less dense, so, or a layer of hot air, so it bends away, then it hits the sand and reflects into our eyes, and we got, so good, this ray when we are far, so we get this ray which is reflected off the sand, and the brain assumes that this ray has traveled in a straight path, so the brain traces back the ray to the point they appear to have originated. So this group of ray appear to have originated from here, so we think that the tree which gives this ray is here. Okay, and therefore we see it how inverted. Okay, so normally light waves from the sun travel straight through the atmosphere to our eye, but light travels at different speeds through hot air and cold air. Mirages happen when the ground is very hot and the air is very cold. So the hot ground warms a layer of air just above the ground. When the light moves through the cold air and then into the layer of hot air, it's refracted away from the normal. Our brain thinks that the light has traveled in straight line. Our brain doesn't see the image as light from the sky. So the real image is here, because this is the actual source of the light coming from here. Okay, but the brain doesn't see that. The brain always trace the ray back to the point it appears to have originated. So our brain thinks the light must have come from something on the ground. So, and usually girls, what do we think? We think that there is a pool of water here which is causing this inverted image of the tree, because you know when we look sometimes when we look at a lake or pool of water, we see like inverted images of the landscape. Okay, so our brain think when we are far from this position, you think that there is a pool or there is a lake of water here that's causing the reflection of rays coming from the tree and giving an inverted image of the tree. But in reality, there is no water, there is nothing. It's because of mirage. So this one, it's a virtual image of the sky. The last video.
Effects of total internal reflection. Total internal reflection is the reflection of light that occurs when it strikes an interface at an angle of incidence greater than the critical angle for the pair of media. Let us now discuss some of the effects of total internal reflection. Mirage in deserts and sparkling of diamonds are some of the effects of total internal reflection.
So girls, here, this one, we talked about it before, the sparkling of diamonds. It's also one effect of total internal reflection, because here as the light enters the diamond is a very dense material, so and the diamond, it has a small critical angle. It's about a 22 degree or 24 degree. Okay, so when the light enters the diamond, it's not easy for this ray to exit the diamond. So this ray that enters the diamond, it makes many total internal reflections inside the diamond before exiting it. Okay, to exit it, the light must hit a surface, a side, with an angle of incidence less than 22 degrees. Okay, in order to exit it, because girls, we said the light refract only when the angle of incidence is less than the critical. If the angle of incidence is equal to the critical, the light makes maximum refraction and the refracted ray touches the boundary. And if the angle of incidence is more than the critical angle, it will be totally internally reflected. Okay, so usually we have many, not only one, many total internal reflection inside the diamond before the light exits it. So that's why we see it what sparkling. Okay, because there is a light which like it's trapped inside it. That's why. Okay, and the mirage, we talked about it already. That's all. Thank you.